Hello, everyone. I'm so excited to talk to you about real world data science. My name is Dr. Frances Boykin, and I've been in the world of data science now for quite a while. Today, I work for AT&T. I've been there for about 18 years and continue to have a background that includes data engineering, data science, and the tools that we use in that craft. So I'm going to hop right in because I know we don't have a lot of time and I have a lot to show you. So let's talk about data science. So Harvard Business Review back in 2012 had an article that said data scientist, the sexiest job of the 21st century. So I know you have heard a lot about the role of data scientist, but I want to talk to you not just about the data scientist role, but about the roles that circle data science and then what those roles entail. So let's hop on. So what's data science? The data science mindset is understanding your audience better. It's using big data. It's using big data tools to help learn about your audiences, their needs, their struggles, their motivations, their habits, their relationships with products or services, or any type of information today that you have a lot of data around. I've seen folks in data science focus on finance. I've seen them focus on the insurance business. So there's lots of application for big data and then building out that for data science. So let's talk about the roles within data science. So there's three main roles for data science. There's the data engineer, the data scientist, and then the business stakeholders. And then there's specific things that you need to understand within those roles to help keep this whole cycle of data science, data, and information going. So as you can see, this is one of my favorite tools here, the data operation. I always mess this word up, operationalization. Woo! The data engineer, along with data monetization and data optimization. Those two pieces go together. And they create that circle that I just mentioned about bringing in the data, the tools, and then building that all out so that the business has something to work with. And those business stakeholders, those are the folks that you take all of your information, all of your knowledge and push to, and they use that information then to make good, sound business decisions that keep our businesses going. So let's talk a little bit about these circles. So we have the business stakeholders, the data scientists, and the data engineers, as I mentioned, and some of the core skills that they use, and then the handshake that goes on between those three areas. The data engineer enables us to capture that data. So it provides us the foundational infrastructure to allow us to have access to data and use that data and build value out of the data. And then the business stakeholder utilizes that data and also provides the impetus to say, hey, this is the kind of information that we need. This is the kind of data that is important to us as business stakeholders. And of course, that data scientist, and we're going to extrapolate from that and really dig in on the whole data scientist piece here. Those are the folks that take all of that raw data, they take that information from the business stakeholders, and they build that into analyses and programming and the stories that come from our data. I'm going to take a second because I see there's some messages here. I like that. It's not sexy, but it can be fun. It can also be a little sexy if you get into all of the creative tools and the algorithms, and folks like myself just get really excited about that kind of thing. The presentation, I'll talk to Amelia and the DSC folks and see if there's a way for us to get the presentation out to you. But that gives you kind of an overall picture of data science and those specific areas, the data engineer, the data scientist, the business stakeholder, and how we take operationalization of the data, monetization of the data, and optimization of the data. And there's going to come a day when I'm going to be able to put those three pieces together without flubbing over that. So hopefully that gives you a good idea of how those pieces fit together. So let's talk about the data science roles. One of the important things about data science is it's not just this data scientist. The data scientist on their own is just a mechanism to build out algorithms around data, but it does not put that data into the hands of the people that need it and build out information that leads to business decisions without these other key players. So you have the data analyst, the data architect, the data engineer, statistician, the database administrator, business analyst, and the data analytics manager. And I'm going to key in on all of these specific roles. So the business analyst, what does the business analyst do? Their role is to improve business processes and act as an intermediary between the business and IT, or the information technology group. A lot of the skills that the data business analyst has to have are they have to understand specific tools, but one of our favorite tools for the business analyst is Excel, so keep that in mind. And data visualization tools such as Tableau. They're conscious storytellers, so they listen and they tell stories around data. And that's what helps us build out business intelligence and provide that information that we can use as leaders to make actionable business insights and decisions. So keep that in mind. So that's the business analyst. The data analyst. The data analyst's role is to collect, process, and they also perform a small amount of statistical data analysis. They're not statisticians, but they do use things like R and Python and SQL to dig into the data and build out analyses. They're usually going to do that in spreadsheet tools. They'll use SQL for that. They have a bit of math, stats, and machine learning background as well. So those are the data analysts. They have a figure it out attitude. So they're going to dig in, they're going to play around with the data. They're going to figure out what the best information is that they can get from the data. And then you have the data architects. The data architects are so important to all of this because they're the ones who build out that infrastructure. They're the ones who move the data to a place where people can access it. So they're going to have data warehousing solution skill sets. They're going to understand data architecture. They're going to understand ETL. ETL is the ability to go out, get data, and bring it to a specific place and land it there. So they build out the blueprint that we use for the data management of all the data that we use within the data science field. You have the data engineer. I own in AT&T a team that has the data engineers. Those data engineers, they develop the architecture, but they also develop the data sets that are important for working across the organization to deliver data. So our data engineers are very important. They're going to have a lot of database knowledge, modeling knowledge, those ETL skills. They'll have API skills, and those API skills are the hooks that allow us to through intelligent use of business systems, go grab data and bring it to a specific place for our use. So that's what we have with data engineers. All right, the statistician. A lot of people who think about data scientists think of it really from the statistician mindset. They're thinking, oh my gosh, I've got to have all the statistical knowledge and all the methodology, and I've got to, have this huge quantitative background in math. That's the statistician. And to be perfectly honest, we don't have a lot of those. Even at AT&T, we don't have a lot of the folks that I would call statisticians. Do you have to have some math background in data science? Yes, you do. But you don't have to be a statistician. Those folks are really good at math. They're really good with algorithms, and they are able to really dig in to the data and build out and interpret that data using statistical methods. I'll pause here for a second. What do you think is the key difference between data architect and data engineer? For me, the key difference between the data architect and the data engineer is the data engineer usually moves data amongst, so they don't necessarily have the architecture background, which means that they don't have the platform knowledge specifically. An architect will build out your Snowflake instance. The data engineer will architect how that data lands in the Snowflake instance. So that's kind of how I separate those two in my head. So let's talk about the data scientist. So the data scientist, they do have some of that distributed computing background. They have the predictive modeling. They have some of the storytelling, the visualization, and they have some of the math, the stats, and machine learning. Do you see something interesting here? They have a little bit of all of the other roles, and they have enough of all the other roles to be able to massage the data and build something out of it. So they clean, massage, and organize that data. And they have to have a curious data mindset. So they have to have this mindset of, hey, what does this really mean? And what can I apply to this data to make it be more meaningful? So that's the data scientist. And then the database administrator. Those are the folks that make sure that the databases themselves stay up and running and available. And then you have the folks like myself. I started out as a business analyst, went to data analysis, then I went to do data science work, and now I work with people and manage people who do that. So data and analytics managers, those are the folks that manage the teams of analysts and data scientists and data engineers. So we help steer the direction of the data science team. And we do that by connecting what we do on a day-to-day basis to what our leaders are interested in. So we bridge that and we ensure that we are working on the projects that provide the information that our leaders are going to need long-term to make those big business decisions that keep us all working. So that's the data and analytics manager. Okay, so here's the important thing in all of that. Those are all great, but how much money can we make? And these are old numbers. I'll have to go back and look for some newer numbers. But this gives you an idea of the progression. As I said, I started out as a business analyst, went into data analysis. I was never a database administrator. I don't have the statistician background, but I do have the data engineering, data architecture background, and then the data science background. And then I started managing folks who do those things. So as you can see, there is a progression. And as you progress along this continuum, you're going to need more and more skills. So for those folks who always ask me, well, hey, how can I get started? Well, there is a starting place. You don't have to start at data scientist. You can start at data or business analyst and then work your way up to data science. Okay, so the next question I always get is, okay, well, that's all great. Well, how do I get there? I will tell you, don't do this. This is one of my favorite slides because it shows what I decided to do. Now, what I thought was, hey, and I did not create this. I got this off of the internet. It's a great slide though. But what it shows you is a roadmap to becoming a data scientist or getting really involved in data science. Now, the cool thing about this and thing that I do like about this is it does talk to you about the fundamental things that you need to learn, as well as the machine learning and the big data and the statistics and the visualization, the tools that you need, the data ingestion operations that you need to understand, the data munging or the data cleansing and movement that you need to understand, as well as text mining and NLP. But what I didn't know then that I do know now is that you can pick your poison. You can pick your focus. You don't have to feel that you have to go through all of this before I can finally be a data scientist. What you can do is focus on the areas. I do suggest that you look at each of the different areas of concentration and then pick some things out of that and dig into that, lean into it, and then go to the next areas, statistics. Pick the things that are comfortable for you and lean into those things as you traverse this. So even though I don't suggest that you use this in its totality, I think it's very cool for giving you an idea of the things that are found in each of those areas. So here's what I consider a little bit more reasonable approach. And it goes back to this three-tiered perspective that I showed when we first started our conversation today. So getting your hacking skills, that means that ability to go in and be curious and dig around. Some of that math and statistics skills, as well as your expertise of the subject area that you're interested in. But one of the things that I do want to show you is that here is the typical background of data scientists. And you will notice that 37% of them have master's or professional degrees. 31% of them, 31% has the master's or professional degrees. Some of 37% have they're college graduates. But there's plenty of folks that go to technical schools. There's plenty of folks that learn through doing and have the high school, and a few people who go back, like myself, and get a doctorate degree. But I probably need to update this, because I would submit that with the prevalence of certificate programs, these high school and technical school percentages are probably higher now, because there's so many ways. And I've actually, at the end of this presentation, I have some great information on learning and how you can go out and learn. Data Camp, which is where I got this, is a great place to learn about becoming a data scientist. Get good at stats, math, and machine learning. Learn to code. Here's some tools that you can use there. Understand databases. We talked about that. Master data munging. Data munging is nothing more than cleaning data. Visualization and reporting. And here are the tools that are there. You can find this out on the Data Camp's website. Leverage up with big data and get some experience. I really, really can't stress this enough. Go out to Kaggle, do the meetups, have a pet project that you just have fun with, and develop your intuition by getting out there and building and becoming, in the project, in the scene, in the data science scene. So get in the data science scene, and that'll help you learn more about data science, and it'll give you an opportunity to stress test some of the ideas, some of the interests that you might have. Also, doing internships, boot camps, getting an entry-level job. We talked about that earlier. Follow and engage in the community. I already mentioned that. Katie Nuggets is one of my favorites. So do go out there and follow Katie Nuggets. That's one of your a great place. And Data Science 101. I love that as well. Some of the tools of the trade. I'm not going to delve into this too much because I know we're running out of time. But R, Python, SAS, Tableau, Excel. You must know Excel. I've told this to many, many people in the past. Whatever tool you use, leadership usually doesn't use that tool. They're usually going to want their answers in Excel. So you do have to learn Excel. R is one of the leading analytical tools. So it is a great place to start, especially if you have a SQL background. Go ahead and start with R. But Python is an object-oriented scripting language that many, many, many organizations use. That's the tool that we use at AT&T, Python. But I do have some colleagues who stick with R. SAS, we used to be a SAS house. We are no longer a SAS house, but SAS is also a great statistical tool. So it has a lot of statistical packages included with SAS that are very helpful when you're doing data science. I also want to mention that Microsoft Excel has included some statistical analysis tools right in Excel that you can get started with. All right, Tableau, I already mentioned Excel, RapidMiner, and KNIME are some additional tools. Data science is everywhere. Just know that you can do data science in so many different fields: travel, automation, marketing, healthcare, credit and car insurance. So, and homeowners insurance, home insurance. So lots of different places. There are great places to learn. You can go out to learn web development. You can learn to game. Pygame is a great tool. Go out there and check that out. Machine learning and artificial intelligence, Pandas, scikit-learn, NumPy. Those are great libraries that include machine learning and artificial intelligence. They're all a part of Python. And then there's all your visualization tools. Seaborn is within, and Matplotlib, that's included with Python. So that allows you to plot graphs and make your data look pretty and easier to understand. I'm not going to go over the business process because I want to hop down and definitely get to the resources. And I will be happy to put these resources in the chat. But definitely take a look at some of these resources, really focus in on data science and all of the requisite roles around in the data science field. I will talk to Amelia and see about getting this deck out to everyone. I think the next session is just about to begin. I'm sorry we didn't have more time to talk because I could go on and on for days about this subject, but be happy to answer any questions. I think at the very first slide, I'm going to skip back there. I'm on LinkedIn. It doesn't show that, but I am on LinkedIn. You can see me touch base with me there, Dr. Francis Boykin. So see you there. Sorry this was so quick, but be happy to answer questions through LinkedIn, and I'll see about getting you the slide. Thank you.